Okay. Yeah. Then the shape, you know, it's a bell-shaped curve, etc. Bell-shaped curve, etc. And I want some 2-3 values now. This is symmetric about mu. In the case of standard normal distribution, the mean is 0, therefore it is about 0. I want to know in between what values 90% of the area lies. In between what values 95% area lies, etc. Okay, that is my important question, because I want all those things in confidence intervals as well as in testing problems. I can use Q function, okay? Therefore, I want 90% here. I want a 90% here. It is symmetric. Therefore, this area is 0.9. Therefore, this area is 0.1 by 2. This area is 0.1 by 2. Therefore, area up to this point is 0.95. Area up to this point is 0.05. Therefore, I can use Q function. I should get values Q, which one 0.05, normal 0, 1. Okay? And I should get Q 0.95. You can see they are symmetric values, 0, 1. This you have to remember. What is error? Oh my God. I have not added the objective Q now. I know that hurry will make me worry, but I am doing the same mistake again and again. Yeah, minus 1.645 and plus 1.645. These two values you please remember. Or you remember how to find the technique. Okay, how to find the technique for finding these values. Okay, that is 90% of the observations lie between minus 1.645 plus 1.645. Okay, then I want to find the interval for 95% probability. Okay, I just change here 0.025. This should be 0.025. This one should be 0.975. That's all. I should get minus 1.96 and plus 1.96. Yeah, minus 1.96 and plus 1. In some books, they are taking it as minus 2 and plus 2. Minus 2 and plus 2. Okay, that means what? 95% of a normal distribution is contained in the interval. Contained in the interval minus 1.96 and plus 1.96. They are called 3 sigma limits. 3 sigma limits. Okay, you might have heard about 3 sigma limits, 6 sigma limits, etc. 3 sigma limits and 6 sigma limits, etc. Okay, that means even though the distribution is spreading from minus infinity to infinity, 95% of the observations are between minus 1.96 and plus 1.96. Okay, we will quickly do 2 problems and go to the next topic. Okay, suppose X follows a normal distribution with the parameters mean 25 and variance 36. Variance 36. What is probability that X less than 28? What is the probability that X greater than 30? What is the probability that modulus of X minus 25 less than 4? Okay, this result we have to use because for each X and each mu and sigma square, tables are not available. If you know the distribution of X as normal with the mean mu and sigma square, then X minus mu by sigma follows standard normal. That is, Z is a linear transformation of X. Therefore, if you know the matters about Z, you can take that to Z. Okay. For example, suppose X follows n mu sigma square. You have to find probability that A is less than X less than B. Okay, this is same as A minus mu by sigma less than X minus mu by sigma less than B minus mu by sigma. Finished. Therefore, this is probability that A1 less than Z less than B1. Therefore, for any normal distribution which is not standard means what? The mean is different from 0 and the variance is different from 1. You can convert that to standard normal. And the probability between A1 and B1 for a standard normal and the probability between A and B of an ordinary normal, they are equal. Okay, that result you have to remember. Okay, this one we have to use here. The probability that's the only thing I have to stress. The probability of X less than 28, you make transformation. Subtract the mean, divide by the standard deviation. That's all. This is less than 28 minus 25 by 6. This is how we do using tables. But in R, it is not needed. In R, it is not needed. Okay? Therefore, this is same as probability that Z less than 28 minus 25 is 3. 3 by 6 is half. Okay, probability of X less than 28 when X is normally distributed with mean 25 and variance 36 is same as probability of Z less than half of a standard normal distribution. I will verify these things. Probability of X less than 28, what is the function we have to use? P norm we have to use. Probability of X less than 28. Therefore, 28. Then you have to mention the parameters. Mu. What was mu? 25. What is sigma? 6. You have to give. Okay. Next one. P norm. It's at less than half. These two things are equal, correct? Probability that X less than 28 when X is normal with mean 25 and the variance 36 is same as probability of Z less than half when Z is normal with the mean 0 and the unit variance. The one table is enough. But in R, no problem. These two should be same. Why? What happens? 28 x minus 25 by 6, 28 minus 25 by 6, x less than 25, z less than half. X 28, 28, 25, 28, 25 by 6. Oh my God. Again, I made a mistake. In my laptop, comma and point, they are neighbors. And I love all my neighbors. That's the problem. Okay. Yes. Again, the problem is there. Okay. Yeah. 0.6914625, 0.6914625. Okay. Therefore, that is a problem. Therefore, this is how you have to use R to find the distribution function. There are tables called standard normal tables. Okay. And if I get time, I will discuss when I discuss the inferential part. Okay. Now comes the second question, probability of x greater than 30. Probability of x greater than 30, you have to use the complementary probability. Complementary probability. That is why I gave that example. Probability of x greater than 30 is 1 minus probability of x less than or equal to 30. That's all. 1 minus probability of x less than or equal to 30. Therefore, here you have to use 1 minus P no. 1 minus P no, 30, 25, 6. Here you remember that, here you have to give sigma, not variance. I think, yeah, 0.202384. 0.202384. And probability of modulus of x minus 25 less than 4. Okay, you have to do a little homework. Minus 4 less than x minus 25 less than x4. Probability that you add a 25. You add a 25. Therefore, this is like this. 21 somewhere here, 29 somewhere here. So what is to be done? You have to take minus infinity to 29. This area, subtract minus infinity to 21. It is always advisable to draw diagrams like this so that we will not make mistakes. Up to 29, up to 21. Okay. Therefore, P no 29, 25, 6 minus P no 21, 25, 6. Finished. Commas are correct. No problem. This is the probability. 0.495, etc. This is a probability that, this is a chance that that variable is between 21 and 29. 21 and 29. Okay. And you can find Condell function. What is Condell function? It is a solution of probability of x less than or equal to x is P. Okay. Then Q no 0.5. 0.5, 0, 1, 0, 1. What's the answer you are expecting? You should get to 0 because area up to 0 is 0.5. Yeah. Okay. If it is mean 0.5, you take mean 25 and variance 1. 25. Okay. It is symmetric about 25. Any questions? Any doubts? If you have doubts, you please ask. I'm sure all these things will come to your help.
So we will practice it, and then we will ask questions in the next
Very,
class.
very good. Okay. Then our three important distributions. One we have already discussed. One we have already discussed, chi-square distribution. Chi-square distribution. X is a normal variable with mean 0 and unit variance. X is a variable, therefore x square is also a variable. If x is having a distribution, x square will also has a distribution. Okay, this x square is known as, distribution of x square is known as chi-square distribution with 1 degree of freedom. 1 degree of freedom. Next one is students t distribution. Students t distribution. Student is the pen name of a mathematician. His original name is W.S. Gossett, I think. Gossett, yeah. He was an American officer or so, something like that. And he was writing the articles in the pen name students. Okay. Suppose x is a standard normal variable. It is a variable. It is varying. And y is a chi-square variable with n degrees of freedom. Then x by root of y by n is also a variable. X by root of y by n is also a variable. Therefore, it is having a distribution. This variable is called t, and the distribution is called t distribution with the n degrees of freedom. T distribution with the n degrees of freedom. Actually, it was a wonderful turning point in the theory of inferential statistics. Because up to that time point, we were taking the normalized variable, the distribution of the normalized variable as standard normal. Whether the population variance is known or unknown. What is the standardized variable? You take the variable, you subtract the mean, and you divide by its standard error. Okay. For example, you take x bar. X bar is a variable. Its mean is mu. Its variance is sigma square by n. Therefore, standard whether sigma square is known or sigma square is unknown, before the arrival of t distribution, we were taking it as normal distribution, standard normal distribution. But Gossett observed that it is not correct. It is not correct. When population variance is unknown, he obtained the distribution of x bar minus mu by root of s square by n. He found that the distribution of this is something different from normal. Something different from normal. He called this as t variable, and the distribution of this is a student's t distribution. As before, dt, pt, qt, rt. They are the functions, are functions for density, cumulative density, quantity, and random number generators. And now I will show you what's the difference between q and t. Normal and t. Suppose you take x is equal to sequence, let it be -5 to 5 at the increment of 0, 1. Okay, then curve denom x standard normal I am taking. Standard normal I am taking. Okay, that is enough actually. If you want, you can give color is equal to red. Color is equal to red. Okay, now let us see. Okay, all commas are correct. Why it is like this? Car deno x 01 minus 5 to 5 x lim is equal to x limit is equal to c minus 5 to 5 deno correct, x correct. Yeah, this is our standard normal distribution. Standard normal distribution. You can see it is almost zero here, no? Almost zero. It is touching. Even if you take minus 3 to 3, you will get almost the same shape. Minus 3 to 3 will also do. Minus 3 to 3. Let it be minus 4 to 4. Minus 4 to 4. Minus 4 to 4. This is a standard normal curve. Standard normal curve. Minus 4 to 4. Okay. And I am doing dp x. For t distribution, degrees of freedom is a parameter. I am putting 30 degrees of freedom. Okay. X lim is same as before. C minus 5, 5. Okay. To make a difference, I am giving a different color. What different I shall give? Magenta. Magenta. Okay. And I have to add with the previous things. Therefore, add is equal to true. Add is equal to true. If I am correct, I should get, yeah. You can see. You can see. To cover magenta and red, they are coming together, no? Therefore, that is not good. That is not good. Let me take 10 degrees of freedom. Color is red is there. Therefore, let us put green. Green. Okay. Now you can see. Green is t distribution. Red is normal distribution. Here you can see T distribution is having a thick tail. Thick tail. The tail area is thick. Normal distribution, it is thin. That's the difference between T and normal. And as n degrees of freedom, okay, as the degrees of freedom becomes larger and larger, if n tends to infinity, these two will coincide. Okay, that also I will show now. That also I will show now. Here you can see for small degrees of freedom, there's a gap. There's a gap. Here it's a thick tail. Thick tail. Okay. Now you look at large degrees of freedom. Instead of 10, you take a 30. Instead of 10, you take a 30. You can. It is very difficult. You see, very difficult to identify the gap. T and normal coincide. Okay. While I started my career as a teacher, it was very difficult for me to explain these things to my students. That is, as degrees of freedom becomes larger and larger, students' distribution is approaching to standard normal distribution. Okay, now it is very easy for me. I will just take this one and I will upload the graph for various degrees of freedom. Then you see, now they are almost coinciding now. Only in some places little gap is there. Therefore, normal probability curve and T probability curve, they are very close to each other. If it is
So
400,
the area under the curve would be always be 1.
sure.
Uh, so then if we plot it in the y-axis in log scale, then the shape would be slightly different.
Yeah, it is y-axis and log shape means it will not be like this. It will not be like
Yes, sir.
this.
Yes, sir.
Yeah, we can. Here the problem is it is minus 4 to 4 now. X is minus 4 to 4.
Yeah.
Then logarithm of negative values, it will create problems.
Okay, sir. Okay, sir.
Normal distribution. This is T distribution. Okay. Then what is the T distribution? Distribution of ratio of two variables. In the numerator, you are having a standard normal variable. In the denominator, you are having a chi-square variable divided by its degrees of freedom and the root of that. And one point is very important. What is that point? X and Y are independent. X and Y are independent. And the last important distribution in our discussion is F distribution. F distribution. Why F is coming there? To respect Professor R.A. Fisher, father of modern statistics. Okay, it is also known as Snedeker's F distribution. Okay, if X is a chi-square variable, with the n1 degrees of freedom, and Y is a chi-square variable with the n2 degrees of freedom, and X and Y are independent, then F is equal to X by n1 divided by Y by n2. This follows F distribution with the n1, n2 degrees of freedom. That is the ratio of two independent chi-square variables divided by their respective degrees of freedom. It is known as F distribution. We will use this distribution in analysis of variance as well as testing the equality of variance of two populations. Okay? Don't worry about these things. All this is very simple. In the beginning, you may find it difficult. Okay, X is a variable. Y is a variable. X by Y is also a variable. Sometimes we are very much interested in functions of variables. Functions of variables. For example, I shall give you a number of examples. Okay, first one. You are installing a machine here. Any starting time can be taken as 0. Suppose that machine is working for a length of time x. Naturally, that is a random variable. Sometimes it may be working for 2 years, 3 years, 5 years, etc. And after x time points, it fails. Then what is to be done? You have to send that machine for repair. And it will take y units of time to get it repaired. Okay, and we assume that after the repair, the machine is as good as a new machine. Okay, now what is this time point? X plus y. Okay, therefore, at the time 0, the machine was good. At the time x plus y, the machine was good. Therefore, again, the cycle is continuing. Again, it will work for a random length of time, and after that, it will fail. Then again, you have to send it for repair, etc. Now, what is the total length of the cycle? The total length of the cycle is x plus y. And out of x plus y, it is working without any complaint for x units of time. Then what is you want? You want to know that probability that x by x plus y is at least greater than 95. Suppose the machine is working for 2 hours and it will take another 5 hours to repair. It will be a great loss for the company, no? Okay, therefore, the working time should be very, very high comparing to the repair time. Therefore, you are interested in the distribution of x by x plus y. X by x plus y, what is that? It's a function of x and y. It's a function of x and y. Suppose in your system, there are 10 units, 10 units. This machine will make x1 errors. This machine make x2 errors. This machine will make x3 errors. All those things are random variables. This x1 may be 0, 1, 2, 3, etc. x2 may be 0, 1, 2, 3, etc. You are interested in what? What is the probability that the total errors, total number of errors is less than 1, less than or equal to 1. Maximum 1 error or 0 error. Then only your machine is, you can claim that your machine is working properly and you can give a 10 years or 15 years warranty. Warranty. If you are giving a warranty for your fridge as 10 years and you promise that if it fails before 10 years, I will replace the machine. I will replace the fridge. That is your promise. Suppose all the machines fail before 6 years. You cannot sell any new machines after 6 years. You have to replace all the new machines with old machines. Oh, sorry, all the machines with new machines. Okay, if you give a guarantee for 10 years means what? The machine should work, the fridge should work at least for 12 years. At least for 12 years. Then only your company will run profitably. Okay, these are the applications in industries, in experiments, in any even LIC. LIC, suppose if I go to LIC and if I ask for a policy for 1 crore, they will not give. They will not give. I am a retired person. I am a retired person and they will not give a policy for 1 crore. They know that I may die any time before that, before the completion of that period. In that case, they have to give 1 crore plus the bonus to my family members. Family members. That is why after 50, after 55, etc., they insist very, very severe medical checkup. And they have to make it sure that I will not die before that policy period. Okay, that is if I am taking a policy for 15 years at the age of 40, they have to make it sure that my lifetime is greater than 55. In that case, they can clear my account by repaying the amount I have given. That's all, plus some bonus. But if I die at the age of 42, all the 1 crore and other things, etc., they have to give my family members. There is a big loss for the company. Big loss for the company. Okay, this calculation is actuarial statistics. It's a very big area. Okay, wonderful area. Actuarians, they are making money nowadays. I am telling this thing because I am taking classes for Actuarial Society of India. Okay, because these calculations are wonderful calculations. If you have some doubts, you can please ask me.
Sir?
Yeah.
Sir, if you have to plot a curve or if we have to plot a graph from a data file, how will we use these things like a p-norm if we want to plot a graph using p-norm?
Yeah, no problem. Yeah. Don't worry. Wait 1 minute. That is all. Wait 1 minute. Wait 1 minute. 1 minute. 1 minute. 1 minute. 1 minute. 1 minute. 1 minute.
So that folder is the company you are just telling, huh?
Which one?
You were telling that you were taking classes for Actuarial.
Yeah, Actuarial Society of India. The students of that. This one. I am taking 2 papers for them. Why it is not opening? Sometimes it is. Or is it already opened? I don't know. Yeah, it is open.
Sir, it is already open.
It is already opened. Let me close it first. Yeah. Electoral Society of India. Yeah, claims. Let me take this. This is their data. This is their data. Credibility. So many things are there. So many wonderful things are there. Actually, after teaching this paper to them, I learned so many things because these were new things for me. Yeah, this one is a data file. Okay, or if you want some bigger data file, I can take that also. Auto claims. Yeah, auto claims. This is their actual data. Gender, age, paid value. Okay, let me file, save as for my convenience. Let it be in the desktop. Okay, and where is my R friend? My R friend is here. Okay, I have to know the address of my dear friend, then only I can send a letter to him. Okay, therefore I have to go to properties, I have to copy this one, and auto claims A and C are capitals, and that is a text file. Okay, therefore my be okay, read dot table. I have to paste the address of the file. And auto claims .txt. Okay, and the first row is header. Therefore, header is equal to true. Okay, I have to make double slashes here. I know that I will get the answer only if I know I have to use double slashes. And if I want to see the head of my D, okay, let me take this one. What happened? My D not found. Oh my God. Auto claims in the place of C. V is also a neighbor of C. That's a problem. That is the problem. Okay. Yeah, file is available. Okay. I have to, first it is better to draw histogram. Hist my D dollar paid. Hist my D dollar paid. This is a histogram. Okay, our experience will help us. Looking at the histogram, can you say that normal distribution is a good fit? Tell me, my dear student, you asked the question. I am asking a question to you. Is normal distribution a good model?
No.
No. Normal means it's a bell-shaped curve. The curve should be a bell-shaped curve. Then you can play games on this. You have to find mean. Okay, mean. What is mean? ID, dollar paid. Mean dollar paid 6127. Okay, 6127. Let us try exponential distribution. For exponential distribution, we have seen what is the density? F of x is equal to lambda into e raised to minus lambda x. Don't worry, only experience can help us. Okay, then what is expectation of x? Expectation of x is integral 0 to infinity x into e raised to minus lambda x dx, you can use gamma integral 1 by lambda. 1 by lambda. Okay, therefore lambda is equal to 1 by x bar. This is an estimate for the parameter lambda. I will explain these things in detail when we do estimation tendency. Therefore, lam, L is enough. L is enough. L is equal to 1 by mean, 1 by mean, my D dollar paid. If you want to see L, you can see L. Okay, now let us plot. Okay, therefore before that, I will use hist my dollar page. Frequency is equal to false. I want the cumulative frequencies, relative frequencies. Okay, therefore maximum will be 1. Then I add a curve. Okay, before that, let me define the x values. X is equal to sequence 0 to some 20,000, 0 to 20,000. It is 0, 1, it will work. I don't worry about that. And the curve DEXP, D for this one. Okay, DXP X. What is our lambda? Our lambda is L. Our lambda is L. Only one parameter is there. And the X limit is equal to C bracket 0 to 20,000. 0 to 20,000. And the color is equal to, let it be red so that we can see. Okay, why it is not coming? Why it is not coming? I know the reason. Can you please tell me the reason? I have forgotten to add true. I have to ask him to add with the previous curve. You can see. It is approximating, correct? Then you try with the gamma distribution. Then you try with the log normal distribution. Okay? Again, gamma with the different parameters you can try. Finally, you will get the suitable distribution. Don't stop. You have to test whether the fitted model is the good model for our data. You can use chi-square test of goodness of fit. That is there in our syllabus that I will discuss in 2-3 days. In 2-3 days, I will discuss that one. Okay. It is coming here. Yeah. Goodness of fits and independence of attributes. Or there are other tests called as Kolmogorov-Smirnov test. Okay. And we have to use that test. Then we will find whether the model is good for our data. Have you got little idea?
Yes, sir.
Yeah, and I am asking the students.
Yes, sir.
Yeah, very good. Now, if you have some other questions, please ask me. I have forgotten. My memory is very poor nowadays. I have asked you to draw 5 curves. Okay, have you done at least one? Do it using ggplot. Okay, you can make your presentations very beautiful. Okay, very beautiful, and that is also important thing, no? You know, okay, some items are very bad in the market, okay, but they will put in a very beautiful cover, that, this, etc., and people will buy it. Okay, some items are very good. Only some people know that that item is good. Okay, therefore only some people will buy that item. Okay, therefore you have to make your presentations very attractive. Then only those papers will be published in very good journals. Okay. Of course.
This is a programming language. We can, from the data itself, we can write a program to find the best distribution.
Yeah, surely.
Yes, sir.
That is what I have done here. That is what I have done here. First, I have taken my data. Then I have tried histogram. You don't stop here because we are not working, computer is working. You can try box plots, my D dollar page. You can see the box plot here, my D dollar instead of $4 is coming. Okay. You can see these are outliers. All these values are very high comparing to the other values. Okay, this is the upper hinge. Okay, from this itself you can see that the distribution is not normal. The distribution is not normal. Then you can try, as sir said, you can try box plot of a logarithm of my paid. We just type logarithm, that's all. He will do the work. Now you see, you are getting a somewhat beautiful thing. Okay, let y is equal to logarithm of my D dollar paid. My D dollar paid. Okay, then you try his to y. Yeah. The distribution was highly skewed before. Now it is not that much. Okay. So many things we can do like this because we can, in 1 hour, we can do so many experiments with the data, and finally we will get some idea regarding the model, appropriate model. Don't stick with one. Okay, play games with the data and make the data a good friend of us. Then it will start telling stories. I have this to give you. I have these secrets with me. I have these secrets with me. Okay, that's all. Don't worry. All those things you can become. All those things you can learn in 6 months and become an expert. Every day you work for 15 minutes. Only 15 minutes a day. Not an Apple day. 15 minutes with your data. Whether it is with the MATLAB or whether it is R, whether it is Python, I don't suggest a particular thing. If you're comfortable with the Python, do with the Python. If you're comfortable with SPSS, do with the SPSS. If you're comfortable with MATLAB, do with the MATLAB. No problem. No problem. Any other questions? Any other questions? Tell me, at least no. I'm asking about students. No side, sir. I'm asking because I have seen our students are not expressing their views. Not expressing their views, whether boy or girl. It is same because you have to tell your views. You have to ask questions. Okay, because all these things are training platforms.
It's clear, sir.
Yeah. Tell me.
It's clear, sir. No problem.
Okay, very good. Very good. Because nobody will give you a job nowadays without entrance examinations, interview, group discussions, so many things, etc. No, you may know so many things. I have seen some below average students. My own students, below average students are in very high positions, and very intelligent students are working as clerks. Okay, because they lack the capability of expressing their items. You should be your marketing agent, or what is the name? Executive. Okay, I know this, I can do this. You should say, okay. You may have so many ideas, so many knowledges, other things, etc. Okay. And if if you don't write in your CV that I have experience in R programming, if you don't write like don't explain that, how the company can know that, how the employer can know that? No, you have to write. I know this, I can do this. Okay. If you have no other questions, you are sitting for 3 hours, sorry for that. With your permission, shall I